Alright guys, this is Mr. Reininger, and we're going to look at the first lesson for this week, which is going to be returning to functions. So now that you have spent most of this year talking about linear functions, and you've learned about quadratic functions, and now we spent the last 2 weeks talking about exponential functions, now we're going to take a look and put all that stuff together and learn a couple of other ways to explore functions and what can happen. So we're going to start with going back to function notation and what it means to evaluate a function and really look at what happens to functions on a graph. So, as usual, you can find this PDF in the folder. You can print it out and take the notes there, or you can copy the notes on your own paper. When it comes to graphs, you can sketch those graphs the best you can. Do not worry about being 100% perfect. Okay, so let's start with, and you do want your calculator. If you don't have a calculator, you can feel free to use Desmos or any other online calculator that you choose. So we're going to start with taking a look at this function here. It says the function y equals f of x, so you'll recall that f of x is the same thing as y. Okay, very important idea, and this is shown on the graph, and it says over the interval -8 is less than or equal to x, which is less than or equal to 8. If you look at the x-axis, you should notice that it just goes from -8 to +8. So when it uses this language right here, it's basically just telling you the x goes from -8 to 8. And we're going to actually refer to that quite often. All right, and so now it says evaluate each of the following. So it wants us to evaluate first f of -2. And if you recall, this right here says that x is -2. And so if they're telling us that x is -2, what must they be asking for? What we don't know is the y value. And so to figure that out, we can go to our graph, and we can go to -2 on the x, and then go down and see where it hits this curve. And it hits at -1 to -3. So when x is -2, f of x, or y, is -3. And another way we could think about that is that's really the point, -2, -3. Okay. F of -8, same idea. So if I go here, this really says that x equals -8. They're asking us for y. So 1, 2, 3, 4, 5, 6, 7, 8. And what's y? 1, 2, 3. Well, look, y is -3 again. So that's the point, -8, -3. See if you can figure out these two. Pause the video and do that really quick. F of 8 is 3, and f of 4 is -1. That would be the point 8, 3, and the point 4, -1. Okay? Alright, this is where we get into something that might be kind of new. Find all the relative maximum and relative minimum values of the function. State the values of x where they occur as well. So if you notice, as we read left to right, this graph increases, then decreases, then increases again, then decreases, and then increases again. So when it says relative maximum and minimum, okay, if you could imagine sectioning this graph off, it goes up, 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 it hits a maximum right here, right there, and then it goes down, 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 hits a minimum right there. Starts going up, 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 hits a max, down, 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 hits a min, and then it goes up again till it stops. So where are its maximums? Okay, I saw two maximums here and here. So what are those coordinates? Well, this one's going to be -6, 2. This one is 1, 4. Those are your relative maximums. And we call them relative because they're happening throughout the graph. Okay? And then we have our relative minimums. We have a relative min here and a relative min here. So this one is -3, -4. And this one here is 4, -1. Those are your relative mins. Okay? So those are the things that happen throughout the graph. Then we get to this next question that actually says what is the absolute maximum and absolute minimum. Okay? Values of the function, at what x values do they occur? Well, what's the highest that this function actually goes, and what's the lowest that this function actually goes? If you notice, the very, very highest this function goes is right there. The very, very lowest this function goes is right there. Okay, so what's the highest value? The highest value occurs at 1, 4. So your absolute maximum is 1, 4. Your absolute minimum occurs here, so that would be at the one that's -3, -4. Okay, so there, see if you can make some sense out of the idea of relative max and min, things that happen throughout the graph, the absolute max and min, the things that happen just once, the very, very highest the graph goes and the very, very lowest the graph goes. And then we move on to other features about the graph. What are the x and y intercepts of the function? We'll look at the x-intercepts. More importantly, how many does it have? This one, I see an x-intercept here, 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 and here. I see 5 of them. So remember that those are called zeros, also called solutions. So I see x-intercepts at x equals -7, -5, -1, 3, and 5. But I only see one y-intercept. The one y-intercept that I see occurs right there at y equals 3. Okay? Give an interval over which the function is increasing. So we go back to this idea of what an interval actually looks like. Okay? And we also think about when I first started reading this graph, what is this graph doing as we read left to right? Increases, decreases, increases, decreases, increases again. So this question here asks, give an interval over which the function is increasing, and then give an interval over which it's decreasing. We have choices, okay? So we can pick whatever we want. I'm going to pick, for an increasing one, I'm just going to say, because I like reading left to right, I'm going to pick this first interval, right here. Okay, the function is increasing from this spot to this spot. But when they're asking for that interval, they're asking for which x values make that happen. So if I look all the way over here, when x is 1, 2, 3, 4, 5, 6, 7, 8, -8, So starting from when x is -8 up until when x is -6, that's when this function is increasing. So that's the way that I'm going to state this. The function is increasing starting at -8 up until when x is -6. So that's one way to write that. You'll see this in other lessons too. Another way we could actually write this, because as mathematicians we're crazy and we have multiple ways of writing things, we could also write that as -8, -6, like that, with brackets. Okay. Now we can pick an interval for decreasing. So just because I want to, I'm going to pick this interval right here. So that starts when x is 1, and it ends when x is 4. So that would be +1 less than or equal to x less than or equal to 4. And again, another way we could write that is 1 to 4. Okay? All right. Asks us to use our graph to find all solutions to the equation f of x equals 3. So what is this telling us? Remember that f of x really stands for y. So this says that y equals 3. So it wants to know the solution. All right. When is y 3? Well, if I take a look, y is 1, 2, 3. That graph hits that orange line 3 different times. What x values do that? Looks like it's when x is 0, when x is 2, and when x is 8. So this one would be x equals 0, 2, and 8. Okay. Lastly, is the function positive or negative on the interval -1 to 3? And how can you quickly tell? So if we look from -1 to 3, all right, so if I look from -1 to +3, is the function positive or negative? So if I look at everything that's highlighted in yellow, oops, is that stuff above 0 or is it below 0? And that's basically the quick way to tell. Okay, so when I look at that, everything is above the x-axis. It's all positive. So that function is positive, and we can quickly tell because it's all above the x-axis. Okay, so this is what it looks like to evaluate the function over the particular interval. All right, and this should bring back memories of everything that we're doing in terms of evaluating with function notation, plugging in x, figuring out what y is, using the graph. The only other thing that I want to do is actually help you recall how to utilize the table and in your calculator to be able to do the same thing. So let's take a look at exercise 2. So here we have a linear function, f of x equals 1/2 x plus 2, and we want to do the following by using your graphing calculator's table function. So you can either use your graphing calculator or you could use Desmos. So this is asking us for f of -6, f of 0, and f of -8. So once again, we'll recall that these are actually x values, and they're asking us for y values. Okay, so what I'm going to do is go to my calculator, and I'm going to go to y equals, and I'm going to type in 1/2 x plus 2, and I'm going to go to my table. Okay, and when I take a look, they're asking for f of -6. So that says x is -6, what is the y value? So if I arrow up to -6, the y value is -1. So f of -6 equals -1. And then I'll do the same thing for f of 0, and I'll do the same thing for f of 8. F of 0 is 2, and f of 8 is 6. So this was 2, and this was 6. Okay? And then the next one here, explore the table to determine the value of x for which f of x equals 11. So just like we did in the previous example, we take a look at what does this actually say. Unlike this one, this is not giving us x. This is actually saying that y equals 11. So I can go to my table and I can see where y is 11. So notice that the y values are increasing, so I'll keep going down. Y is 11 when x is 18. So y is 11 when x equals 18. Okay? So you should be able to use your calculator to complete all this. I shouldn't need to go over that with you. Again, we see this idea of interval notation of -6 to 6. Your x values just go from -6 to 6. So you could get your y values, plot those points. If you're not using this worksheet yourself, you could just sketch it. And then here's another line that they want us to graph. Those two lines should intersect, and you can find where those points intersect. When we look at the next example, hopefully you recognize that this right here is a quadratic. So they want us to look at that quadratic over this interval. So again, your x values go from -1 to 4. And we want to use our tables and our graphing calculator to figure this out. So let's create a table of values. Okay, type that into y equals, and copy to your table just for these x values. So I'll put 4 over here. It'd be 0, -3, -4, -3. Then 0, 5. Okay, so what are the function's minimum maximum values on this interval? Very important. Since this is actually a parabola that's going to open up, and we should be able to see that if we graph it. Keep in mind that this does not actually have a maximum value. Okay, technically there's arrows on here, so it's very important that we notice that it says on this interval. So what is the maximum value on this interval? Well, the highest y value I see is 5. So the max occurs at 4, 5. And the minimum that I see, the lowest value that I see here, occurs at 1, negative 4. Okay? Over what interval is the function negative? Well, if we really think about where is the function negative? Okay, here, is it positive or negative? Is it above the x-axis or below? If you're saying positive, you're right. Here it's negative, still negative, still negative. Even though the function's increasing, it's below the x-axis, so the values are negative. And then here it's positive again. So from here to here, everything, all the y values would be negative. And that occurs when x is negative 1 all the way up through when x is positive 3. Okay? So what that means, when x is negative 1, the value of y is actually 0. Same thing with 3. So the way this one would actually be written is negative 1 is less than x, which is less than 3. We don't include them this time because at that spots, the y value was actually 0. It's not negative. And so with this one, the other way it could be written is with parentheses like this. Okay. Now, when's it increasing? So we take a look at this graph. And again, really, I should just be looking at this interval right here from negative 1 to positive 4. I shouldn't be looking at this entire graph. I should just be looking from negative 1 to 4. So from our graph, from this interval, when is the graph increasing? Maybe it would help if I did this. Negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3. That should have been there. So there's my graph. Obviously, it's not very good, but it'll serve the purpose. So over what interval is it increasing? Okay, so starts increasing here. All the way up to here. So it's increasing when x is 1 up to when x is 4. So that would be 1 to 4. Okay. How can this graph help solve this equation? How can we solve it using our table? So, how does this look different than this? Look really carefully. What's the only difference? If you notice, what's this? If you're thinking that's y, you're correct. This is basically just saying that f of x equals negative 3. So, when is y equal to negative 3? Okay, if we take a close look at that, y is equal to negative 3 at these two locations. So that happens when x is 0 and when x is 2. All right, and we can see that in our table also. We can see that when x is 0, y is -3. When x is 2, y is -3. Now technically this question says, how can the graph help us? So you would have to actually explain that instead of just answering it, but that's what we would be looking for. Okay, so sorry this video is a little long, but this is what it looks like to analyze these functions on the tables and the graphs, and to analyze the function notation. Try out the practice questions. Let your teacher know if you have any questions. Thanks.